So today we're going to start chapter 9 and we're going to talk about the hypothesis tests. And we're just going to do part of this first page and then we'll do a worksheet with more examples, more practice problems. The second page of this file will be used in the next section, 9.4, when we start understanding the conclusions. Today we're just going to work on a hypothesis test setup. So a hypothesis is just like in science. It's a claim or statement about a property of a population. So property meaning the mean or the proportion. That's what we're going to be talking about in this section. In this class. And so just an example of a claim, what a claim would look like. Medical researchers claim that the mean body temperature of a healthy adult is not equal to 98.6 degrees. So some key things I see that we're talking about the mean, and then it makes a claim, in this case, not equal to 98.6 degrees. So it makes a claim of either equality or inequality, including less than and greater than to some number. So a hypothesis test is the test we're going to do to test the claim about the mean or about the proportion of a population. So here's an example. We're using a pH meter to test the acidity or alkalinity of a solution used in a manufacturing process. The meter is tested each morning to make sure it is operating correctly. And we have 4 samples that are tested. And it gives us the pH of pure water right here. So the pH of pure water is 7. Suppose that in 4 tests, we get these 3 different meter readings. Is there evidence that our meter is out of adjustment? So you might have an opinion on this. You might see, okay, well, it's supposed to say 7, but I'm getting numbers that aren't 7. Okay, that's fine. But remember, we don't base things on feelings in this class. So we are going to determine if the average of the 4 readings is sufficiently near. If it's close enough to 7, then it's in proper adjustment. So we're going to figure out what that close enough means. So we have 2 hypotheses. We have our null hypothesis, that the meter is properly adjusted, and our alternative hypothesis, which is that it needs service. And so here we have this notation, H sub 0, that's our null hypothesis. And we're saying the mu is equal to 7, the mean is equal to 7. And for our alternative, we're saying that the mean is not equal to 7. So one thing to start off with is, we'll get to that in a minute. Right now, we're just looking at the notation. So we have null is H sub 0 and alternative is H sub A. Now, the top one, let me just cut this in half just to make it easier to see. The top one is always equal. And then the bottom one can be less than, greater than, I'll write this down, can be greater than, less than, or not equal. And we can even have, so up here we could even have, well, I'll get to those other examples in a second. So let's look at some pictures. There's 3 scenarios. The 3 scenarios being greater than, less than, or not equal. In this first case here, we have that our alternative hypothesis is greater than. And so there's 2 symbols you can use for the null hypothesis. What I wrote here, mu is less than or equal to some number that we're given, or you could even have it as just equal. Mu is equal to some number, or P is equal to some number. You don't have to have that greater than or less than part in there. You can have just equality. Because what we're looking at, and I'll go to the picture on the right-hand side, we're looking to what region does everything fall. So using H, that 1 right there is just another way of writing it. Using our alternative as greater than, I'm going to look and see I have this reject region over here colored in red for greater than. Anything else is not greater than. So it doesn't matter if you have the equal to or the not equal to. All of this part right here is we would fail to reject. That would be our conclusion. Whereas the red part is our reject region, where we would reject the null hypothesis. We will talk a lot more about these claims and what they mean in the next section. This section, we're focusing mostly on the symbols. So yes, I am telling you these words, and I'm talking about the reject region, and I'm talking about failing to reject the null, but we're not really going to define them until the next section. What I want you to make sure you're getting in this section is the symbols, the notation that we're using, and what type of test. So wherever the reject region is, so the part that I colored in red, you'll notice is the right side. And so this is a right-tailed test. Just like in chapter 6 and 7, we're going to be drawing lots of pictures, and so we need to know which side is being shaded in. It is right-tailed because the null and the alternative is greater than. All right, so using that logic completely opposite, we have case 2. And case 2 has our alternative as our less than symbols for our alternative. And again, you could just write these null hypotheses as equal to. Oh, look, there's a wayward P naught. That doesn't need to be there. Okay, and then mu is equal to mu naught. It's fine either way. If you want to use the greater than or equal to, because that's the opposite, or you want to just use the equal to, either way is fine. But the thing to focus on is that this is a less than situation. Our sign used for our alternative is less than. So the alternative, the less than, that is our reject region. Over here, we would reject the null on anything on the left. So that makes this a left-tailed test. Anything on the right, anything greater than, is now the fail to reject. That we fail to reject the null. So what we're focusing on is the symbol of the alternative, and that direction is the test that we would use, left tail or right tail. So I said there's 3 scenarios. The 3 scenarios, less than, greater than, we already covered. And this last scenario is the last type of inequality that we have, and this is not equal. Well, not equal could mean more and it could mean less. And so not equal for our our alternative hypothesis means I need to consider both sides, the left and the right. So I have 2 reject regions, one on each side, and then anything equal or in the middle would be fail to reject the null. Again, we'll get a lot more into what fail to reject means, what reject means. Right now, I just want you to focus on the notation, the symbols, and what test we are using. So this one, because it's on the right and the left, we call it a 2-tailed test. Okay, so I know there's another page here. We're going to come back to that in the next section. Right now, what I want to look at is the worksheet that goes with this to practice. And so I'm going to do some, and then I'm going to recommend for you to pause and try some on your own, and then come back and we'll keep doing that, because this is something that I would do in class and have you work on a little bit at a time and then checking in on the answers. So if you're getting the hang of this, by all means, just pause it, do the whole worksheet, and then come back and check your answers. But I will do it in little chunks as well. Okay, so first thing we're going to do is figure out what we're talking about. We're not even using the symbols yet. Although before we get too far, I do want you to notice I put this little chart at the top. So you can use any of these symbols for the null or the alternative. I don't recommend the or equal to. I do recommend equal to. I don't recommend these 2 scenarios just because it's a lot easier as we get into hypothesis testing to say the null is always equal and then let's see what the alternative says. Okay, so you're testing the mean speed of your cable internet connection, or testing that the mean speed is more than 3 megabits per second. So what is the random variable? In other words, is this going to be a mean or a proportion problem, and what are we taking the mean or proportion of? And so I don't want 3. I don't even care about the more than. That's too specific. I just want to know the variable. So the variable is the mean speed or I guess the mean speed of the internet in megabits per second. All right, so we can tell based off of what we just wrote that we're talking about the mean. We're taking the mean, we know what it's of, and we also know the unit. So those will be, all 3 things will be important as we move into the next section and do a full hypothesis test with a conclusion. All right, number 2, the American family has an average of 2 children. So it's just a statement, but I do see the word average in there. So this is definitely mean. Remember, we've been spending a lot of time in various sections, or at least in chapter 8 and now 9. Is this mean or is this proportion? So you know the key words. You know average and you know mean. Mean. Should get $1 every time I say the word mean. Okay, or you know the other one, probability, proportion, percent, all the P words go together. So this is mean. So here, if the question is asking about, or the question that would be asked to do this problem, if the answer is the average American family has 2 children, then we would want to know the mean, or without the number 2, we're talking about the number. Oops, I forgot my word. I just said I should get $1 for it. All right, I'll owe you $1. The mean number of children an American family has. So the claim is that an American family has an average of 2 children. So if we were to test that claim, then we would be testing the mean number of children that an American family has. All right. So finally, because this is the last problem in this section, and then we'll go to number 4, it's a little different. A sociologist claims the probability that a person picked at random in Times Square is visiting the area is 0.83. And we want to test to see if the proportion is actually less. And so what is the random variable? So take a second, pause it. I'm not going to pause for too long, but pause the video and see if you can write that out. All right, so now that you're back, we have the proportion. Because we are not talking about mean in this problem, we see the word proportion. The proportion of people picked at random, or yeah, we'll just go people in Times Square that are visiting New York. Okay, so now that we have an idea of the things we're looking for mean, we're looking for proportion, we're going to start writing out the null and alternative hypothesis. And so for this first one, so what I like to do to start is I say, here's my null, here's my alternative. Okay, next step, what am I talking about? I can see, skimming through the problem, that this is a proportion problem. So I am talking about P. All right, so that's step 1. Step 2 what is the claim? What number is the claim? In a population of fish, approximately 42% are female. So 42%, we always write as a decimal in proportion problems because proportion is the decimal version of a percent. And then finally, we need the symbols. And so the null is always equal. And then for the alternative, I want to look at the claim. So I'm claiming, I'm doing a test to see if the proportion is less. And so I put less than. There's only 3 choices: less than, greater than, or not equal. And we can get that from the top here. We have less than, greater than, or not equal. Those are our 3 choices for alternative. For null, we're just going to put equal. Now, just a little side note. You could, some people like to do this. They have the alternative is less than. So then the null is going to be the opposite of less than, and the opposite of less than is greater than or equal to. That would cover the whole spectrum of numbers. We have the numbers less than 0.42, we have the numbers equal to 0.42, and we have the numbers greater than 0.42. I just like the equal sign. I just like to always put that the null is equal. I even put it right here in parentheses, and so I'll just put a little heart by it so you know that, oh, actually I had a heart in there. All right, put a little heart by it because that just means that I like that way because I think it's easier. But I do like to give you a little bit of freedom in this. Okay, number 5, we have a random survey of 75 death row inmates. Reveal that the mean length, okay, so I'm already noticing that we're talking about the mean. The mean length of time spent on death row is 17.4 years with a standard deviation of 6.3 years. If you're conducting a hypothesis test to determine the population mean time on death row could likely be 15 years, what would those 2 hypotheses be? So there's a lot of numbers in this problem. We're definitely talking about mean. I see it written there again. So I'm gonna write it down here just because my pen is so fat. It's not gonna fit on that line. But we have a problem where we're talking about the mean. And then there's a lot of numbers in here. So we need to look at the claim. If you were conducting a test to determine the mean time, if the mean time could be 15 years, what would those 2 hypotheses be? So we're talking about 15. That means the other information is just random information. We'll actually use that kind of information in the next section, but not today. Today we're just practicing the 2 symbols, the null and the alternative. Okay, so we want to know if the mean time is 15 or if it's not. And there's no clear, is it 15 years or less? Is it 15 years or more? It's just saying, is it 15 years or not? So our null is always equal. And since there's no clear greater or less than in this problem, then not 15 would be that symbol right there, not equal to 15. All right, so I'm gonna do one more problem and then I'm gonna give you some time to pause and finish up this by yourself, and then you can come back and see how you did. But we have this problem right here, and it says mu is equal to 9 is the null, and mu is less than 9 is the alternative. So this is a less than problem. So I'm drawing a picture. So you could go back to that chart. Where's my chart? You could go back here and say, oh, less than right here. I see that written out. I could tell what picture it is. But that's going to take a lot of time if you're always having to go back to that chart. So a better idea would be just to kind of understand how it works. So if I draw this picture, less, and it tells you right here in the symbols pointing to the left, less is always on the left-hand side. So I would have a picture that looks something like this. Mu is 9. And so the question is this a left or right tail test? This is a left tail test because it's less than. The tail part, the part that's shaded in, is on the left-hand side. This is a huge deal in the next section when we're going to start going to tables. You need to know if it's left, right, or two-tailed. So this today, it kind of seems like it's not really that in-depth, and you're absolutely right. This is just an intro. This is not very in-depth, but we will be using all this to mean something in the next section. So what I want you to do now, I even made a cool slide for it, is to pause the video and do 7 through 11. And then after you're done, unpause and come back and check your answers. And we're back. So here we have our worksheet where we left off on number 6. And so for 7, we have a situation where it doesn't say less than or greater than. It just says it's not equal. And notice I don't care about P or mu when I'm looking at this picture. Both of the situations, whatever it's equal to, is going to be that number in the middle. Oops, got my decimal on the wrong side. Is that number in the middle. And so not equal means I don't know if it's less or greater. So this is a two-tailed test. Okay, so now I don't have it written out so obviously. I don't have the null and alternative, so I'm going to go ahead and write those first. So for this problem, I'm looking at the mean, and the number given is 63. Null is always equal, and the friend, what we're trying to test here is that it's higher than or greater than, and so greater than is over here on the right, so this is a right tail test. Number 9, flip a coin. We know the probability of getting a heads is is 50%. Now it does not say the word proportion or the word mean in this problem, but probability is a P word. All the P words go together. So for our null, let's see if I'm still on highlight. Back to my pen. For our null and alternative, we're going to be using a P, and we're talking about the probability of 50%. So our alternative is half. The claim is that it is, oh, I'm sorry. What am I doing? I meant to write that up here. The null is equal. There we go. The null is equal, and we have, my dog just dropped a weight off of it so fast I got a little distracted. Okay, the null is equal. We're talking about less than, so our claim, our alternative hypothesis is less than, left is a left tail test. And hopefully, at first you're probably looking back at that picture from that other worksheet. Great. But hopefully as you're working through this, you're starting to notice some patterns: less than left, greater than right. And so then you won't need to rely on that chart as much, but definitely keep it handy because we will be using it in the next section as well. All right, so now we have another problem here. It tells us, now this one, it says the mean is at least 18, is our null hypothesis. So technically, our null hypothesis is the mean is at least 18. Go back and think about going on that roller coaster. If you have to be at least 18, well, probably not a roller coaster, maybe getting into this club. To get into this club, you have to be at least 18. Who can go? 18-year-olds can go, and greater than 18-year-olds. So greater than or equal. The reason we need that written like that is so that we know what our alternative is, because our alternative is the opposite. If I used greater than for the null, I'm going to use less than for the alternative. The only reason I did it this way is because the problem said the null hypothesis states that the mean is at least 18, and I kind of reverse engineered to get to the alternative. You could, once you get the hang of it and you kind of are more comfortable with the phrase at least, you could say at least 18 means the bottom has to be smaller, the alternative has to be smaller, and the top is equal. Either way is fine by me, but that alternative needs to be less than, and since it's less than, it is a left-tailed test. All right, finally, the null hypothesis states that the mean is equal to 88. Is equal to 88. And it says the alternative states that the mean is not equal to 88. So that was pretty cut and dry. I just copied down exactly what it said using symbols. So since I have a not equal, did we draw a picture of a not equal? Yeah, number 7 was the not equal. So this is a two-tailed test. All right, so that is it for this section. And we will get into this a lot more about hypothesis testing in 9.4. We're going to spend a few days working on 9.4.